This video just talks a little bit about MIDI sound. It's a small topic in A level, but it's just to help us think a little bit about how that works compared to sampled sound that we might have looked at already. So sampled sound, as we know, we sample an analog signal and convert that by a process of quantization into digital file, and then obviously to get that so we can hear it again, we need to convert it back with a digital to analog converter, and we store all the data that we recorded and that we converted by the quantization in a file, and we could compress it. And we've probably looked at a few techniques, or you might have looked at a few techniques for compressing, and you can play it back through a piece of hardware so we can hear it. They make quite large files, and we're going to look today a little bit about what we could do with something called MIDI instead. So in the spec it says that we should be able to do this. We should be able to describe the purpose of MIDI and the use of event messages, describe the advantages of using MIDI for representing music. So we could think about MIDI as a little bit like vector graphics. So vector graphics describe how to draw a picture rather than storing the pixel data. And MIDI, which is musical instrument digital interface, so MIDI has a set of event messages, and those event messages describe how to play the music. So these event messages, they're about 2 to 3 bytes of data, and they control all the properties of the sound. So we might have, when to start playing the note, when to end playing the note, what the pitch is, what the actual note is, how loud we might play it. There could be effects on it, sort of reverb, different forms of attack and decay. So we can edit it to a great extent. So we're not storing any actual sounds. There's no actual sound stored. The actual sound data is not stored in the file, but just the events and how to play it. So we get a lot of event messages, and then we put them together in order to play a piece of music. So therefore the files tend to be much smaller than a sampled file size would be. The other big advantage of MIDI is that you can edit the notes. So once you've created a MIDI file, it might look something like the one over here with various tracks that have been recorded or specified. So we can change individual notes, we can change individual pitches. So if we want to change key change is really easy with MIDI, because we can just tell it to change the key of all the notes in the same order. So therefore it's really easy to do. Essentially it's just a press of a button for us, and we don't have to re-record anything. Nothing like that needs to be done. So we can change and edit that sound and compose in an algorithmic way. So you can usually use MIDI to output a score as well. So you might output a musical score like this one here from a MIDI file. So there are a number of advantages of using MIDI, and there's a question here that we have that came from one of the previous papers. So MIDI files are nearly always smaller, so they're a much more compact representation of the sound. They're very editable, as we said, so you can edit individual instruments and select them, modify them, change the notes, etc. They're very authentic, often representation if you've got good hardware. Now, we could say they're better quality, but we have to be careful about better quality. And as I've said here in this little box, don't say it's better quality in an exam without explaining why that might be. So because there's no actual recording of live sound, then there shouldn't be any background noise. There's no quantization error from the sampling process, because we're not sampling. So therefore you could argue that it's better quality, but just be careful in the exam. If you're saying better quality, say why that's the case. So we could output a musical score, as we said. We could algorithmically compose, so we could get a computer or an AI to compose some music for us using MIDI. And we can directly output to an instrument. So basically what we're doing with MIDI is recording the musician's inputs. So if they press a key on a keyboard, we can record that and use that to create a MIDI file, but there's no recording of actual sound signal. Okay, so if we had a question like this one, or these two questions, describe how music's represented using MIDI. So the first thing we'd say is that it's represented by event messages. And, you know, we could say that those event messages represent a piece of music. But that's kind of enough for the beginning. So it's played by sequencing those event messages. And each message could hold note on or note off, pitch, etc. So we don't have to describe all of the things there, but we're going to get the marks here that we're representing using event messages and sequencing those messages, and that the messages could hold these ideas. So an example is normally going to get you a mark. Only one advantage that we need to explain here about MIDI and why MIDI's an advantage over sampled sound. The easiest one to do is just to say that MIDI file sizes are smaller than sampled. So we could say that. We could say other things like it's easy to change between instruments, that as we've said here, it's easier to compose algorithmically, that you know, we could make the quality idea if we really wanted to. But for this one mark, much the easiest one to get the mark for, really, to remember, is that MIDI file sizes are smaller than those for sampled sound, and we will get a mark for that. If you want to remember another one, it's easy to modify notes, or it's easy to modify at a note level, if you like, is another one you could say. But we've had a quick look at the idea of MIDI and why MIDI might be advantaged over sampled sound. So describing the purpose of MIDI, so it's to represent sound as a set of event messages, as a bit like vector graphics, so that it can describe the sound rather than recording all of the analog sound. And advantages, we've looked at a load of advantages down here. We thought about all these advantages there, and we managed to write one of those down for the answer to that question.